This is chapter number 3, current electricity. When the charge is at rest, the study is known as electrostatic. But when the charge is in motion, the study is known as electric current. The charge can have two types of velocities. One is a constant velocity and a variable velocity. Constant velocity means magnitude of the velocity of the charge and the velocity remains same. It is called as constant velocity. When the charge has constant velocity, the study is known as current electricity. When the charge has variable velocity, change in magnitude or change in direction, it is known as, the study is known as electromagnetism. It is about the study of the property of the conductor, electrical conductor, which conducts electricity. Conductor means which is the one which conducts electricity. So there are materials. We study about the property of the material, especially the conducting property of the material. So this conductor, that is a conductor in the cylindrical shape, we have applied the potential difference between the ends across the conductor. Between these two ends of the conductor, one is positive potential, other is negative potential. Potential difference if you apply. When this potential difference is applied, there we see electric field is produced in the material. Electric field is produced in the material conductor. This electric field will cause the flow of electrons. What electrons? Free electrons. So conductor has some free electrons for conductivity. Electronic conductors. I am talking about many electronic conductors. In electronic conductors, the charges moving are electrons. In some other conductors, or what is that? Liquid conductors or gaseous conductors, the charges moving are ions, positive ions, negative ions. If the electrons, that is these electrons are the charge flowing or moving. So this production, that is what the electric field is produced in the material, will cause the flow of these three electrons in the material. The electrons always move in the direction. What direction? Direction opposite to the electric field. Very important. Electric field direction is from positive potential to negative potential. This is the direction indicated, direction of the electric field. This is the direction of the electron flow. It is always opposite in this direction. If the electrons flow, this flow of electrons or flow of charges is known as electric current. What is electric current? Electric current is the flow of charge in the conductor. This electric current, the direction of the electric current, you see that it is in the direction of electric field. It is in the direction opposite to the flow of electron. So this current direction is opposite to the direction of, that is, charge, negative charge, or is the same as the direction of positive charge. Positive charge move in this direction. That is the direction of electric field, direction of electric current. In this electronic conductor, electric current flows in the opposite to the electron flow. This electric current, that is I, as you know, is a form of power transmission. Electric current is a kind of power transmission, is a form of power transmission which you see in our daily life. It is man-made device by which we see the transmission of power from one place to other place by electricity, that is called electric current in the material, using materials. So this electric current, let us talk more about this electric current. I is a symbol for electric current. So when I apply this potential difference across this, that is between these two ends, this is the length of the conductor. This amount of electricity produced, that is intensity of the electric current, V and I. About this electric current, as you know, it has both magnitude and direction. But one thing is clear, electric current does not obey what is the property of vector, mainly does not obey the law of vector addition. So in that sense, so we are treating this electric current as a scalar quantity, even though it has, that is, as direction, but just because that electric current does not obey that law of vector addition like other vectors. So this current or intensity of the electric current, this electric current can be defined by the mathematical, there are a number of mathematical equations by which we can define electric current. One is electric current I is defined by this equation dq by dt. dq by dt. What is this mathematical equation says? It is a rate of flow of charge. dq by dt is a rate of flow of charge in the conductor. Charge is electrons, of course. So that is rate means charge. How much of charge flows or pass through this cross section of this, that is cross section of this conductor in the unit time, in this given time. That is the amount of charge flowing in this time, that is crossing some cross section of this conductor. So that is called as electric current. So it is given by the unit, that is coulomb per second. So many coulombs per second. So this coulomb per second is called as ampere. Ampere means A stands for symbol ampere. So if 1 coulomb of charge pass or cross, that is certain area of cross section in 1 second, it is called as 1 ampere. That is definition for 1 ampere current. A stands for ampere. That is one definition. And another definition is from the Ohm's law. Ohm's law is equal to V equals Ri. That is, V stands for potential difference applied between these 2 points. And the electric current strength, that is current intensity, that is produced in the material, is I. These two are directly proportional. So electric potential is directly proportional to the electric current. This R is called as proportionality constant. So proportionality constant is called as resistance electrical resistance of the material. As you know, this electrical resistance is a property of this conductor. Every conductor or every material, they have, what is that? Resistance means a restriction to the flow of charge. Restriction to the flow of electric current. So every material, by virtue of nature, has both restriction and permission. That material has both restriction and permission for the flow of charge or the flow of current. But degree of this, that resistance and flow, that is free, it is permission for flow is called as conduction. Permission for restriction is resistance. So resistance and conductance both are inversely related, but degree of them are different. If the material has higher degree of conductance or lower degree of resistance, it is called as a good conductor. If the material has, that is, lower degree of conductance, higher degree of resistance, it is known as insulator or low conductors. So this every material by nature has both characters, restriction as well as permission for the flow of current. So this is the resistance for the electrical conductance. So in accordance with this equation, I is equal to ratio of V R. So that is potential difference applied, potential applied divided by the resistance of the material. So volt per ohm, it is also unit. It is a unit. By one more equation, the electric current is defined. That is by this equation. So the I is a product of all these four quantities. Vd is called as drift velocity. Drift velocity is a defined. I will define it later. Also, we have derivation. Drift velocity of this electron. Electron velocity due to this electric field in this direction. Drift velocity of this electron. E stands for the charge of the electron. As you know, the charge of the electron is 1.6. That is into 10 to the power of minus 19. That is Coulomb. N stands for number of free electrons. As you know, these electrons are free electrons of the conductor. N is conductor. So that is the one accounts for the conduction, free electrons. That is valence electrons, one or two electrons, one or more electrons of the valence electrons of the atoms it is composed of. They are called as free electrons, accounting for conductance. Number of free electrons, not only simply electrons, number of free electrons per unit volume of the conductor. In unit volume of the conductor. And A stands for area of cross section of the conductor. Area of cross section of the conductor. So this I is a product of all these quantities. So the expression for Vd is equal to this. It is called drift velocity. We will define it and derive it in the next step. So using this mathematical equation, we can define I, the number of I's, by different quantities. But approach remains same, I, current. So let us go for definition of drift. Let us go for definition of drift velocity and derivation. Now it's a material. What is a material? Conductor. As you know, conductor means material. The atoms are fixed, and after losing one or two electrons, one electron suppose, they become positive charge. That is positive charge. These positive charge are positive, and cation are fixed, just like atom. They are fixed in the state. These electrons, after losing, then become what is the free electrons. These electrons are freely flow in the material. These atoms are they are the kernels. After losing electrons, they are called as kernels, carrying positive charge. They are fixed in the crystal, in the conductor. And this electron, what is the free electron? Let us talk about the movement of electron. And every material has what is that heat content. What is heat content? That is thermal energy stored up in the material, room temperature. Because of temperature, material temperature, some amount of thermal energy stored up. That thermal energy or IR radiations or heat radiation will cause this, what is that? In this case, this will cause this fixed atoms or kernels to oscillate about their position, that is oscillation or vibration. That is because of thermal energy. And also the electron is free now. It can able to move because of this thermal energy. They gain thermal energy, heat radiation, and electrons are move. They are not stand still because of temperature. Electrons keep moving, freely moving in the material. What is a movement? That is, what kind of movement electron will follow in this material? Look at this. Okay. Electron commencing from here and will reach here, one more kernel colliding against this kernel. Change the direction. Until then, straight line. When the electron after the collision change the direction, it will move in this direction. Gain thermal energy, move in this direction. And collide with another kernel. Then change the direction. Like this. Collide and change direction. Look at the direction. There is no one direction, that is random direction. No regularity in the direction, but movement is there. Random movement. Electrons are moving randomly in all direction. So direction, net direction, what is that? No net direction. And when you look at this electron gain what is that velocity because of thermal energy. Here after the collision, electron velocity becomes 0. Here electron velocity after collision becomes 0, initial velocity. And electron gain velocity, that is velocity increases due to acceleration. That acceleration due to thermal energy. Electrons accelerated by thermal energy. Accelerated and increased velocity. By the time it reached for collision, velocity is v, final velocity at time t. What is t? Time of interval between the two collisions. So from here, that is time taken for the electron to travel from this kernel to this kernel is called t. That is called relaxation time. It is known as a relaxation time. So at this time, that is time from here to here, velocity is v. So this is the usual notation for velocity. Initial velocity, velocity after time t, it is accelerated due to thermal energy. This v is equal to at because u equals 0 initially from here to here. So every time here velocity, this is called average velocity. This a acceleration due to thermal energy. But there is no net because of due to random movement, no net movement in one particular direction. If there is no net movement, that net velocity equals 0. Electron is moving, electron has velocity, all the electrons have velocity. That velocity is called average velocity. But this net velocity is 0 because no particular direction, because of random. Net velocity equals 0 due to thermal. So what is the amount of velocity that electron can gain maximum is 10 to the power of 4 meter per second. Quite a high velocity. But when you apply the potential difference, that is in presence of electric field. In presence of electric field, what happens? There is acceleration by thermal energy. acceleration due to electric field. In addition to this acceleration, there is one more acceleration that is due to electric field. That acceleration is called as, what is called, this acceleration is called as acceleration of the electron due to electric field only. This velocity is 0 because of random. This acceleration is not 0, that is net acceleration. It has a direction because this electric field has direction. This electric field produces acceleration in one particular net, there is a net acceleration in one particular direction. What is the direction? This is the direction of the acceleration. And hence velocity. This is the direction of the velocity. Because acceleration and velocity are both are vectors. Look at the difference here. This velocity by thermal energy is 0, but velocity, net velocity by electric field is not 0. Some velocity, that is velocity, this amount of velocity is very less, 10 to the power of -4 meter per second. Compare them, very high, very low. Very small amount of velocity due to electric field. So there is of course a tug of war between this acceleration and this acceleration. Net acceleration, very small amount. So as a result, very small velocity called velocity drift. So some velocity is drifting towards this in one direction. It is overall non-direction, one particular direction. Some velocity is drifting due to electric field. It is called drift velocity. So this drift velocity can be calculated. So this drift velocity is not because of thermal energy, it is because of electric field. What is the amount of drift velocity? That is same as this equation, AT, written AT. It is due to electric field. This T is same, it is relaxation time. Same T here. Calculate what is that acceleration due to electric field. Recall this equation, same equation. Since electron is an object, this is for electron I'm writing. F is equal to ma, usual notation for electron. A is equal to F by M. So F means electric field, force, electric force. Mass means mass of electron for electric particle. So high electron is an object. Electric force by mass. So what is electric force in terms of electric field? As you know, electric field into charge. Recall this. F and E, that is E into Q. What is Q? Charge of the electron. Because we are talking about electron. Electron. What is electron charge? Minus E. Why minus? Negative charge, because magnitude of E is 1.6 10 to the power minus 19 joule. Sorry, Coulomb. So this is minus EE divided by M. What is M stands for? Mass of electron, electron charge, electric field applied. Now we are see that acceleration of the electron due to electric field is this. Substitute into this. We get what is VD. Drift velocity is equal to minus EE divided by M into T. Rewrite this as this. So in this equation we have what is the drift velocity and electric field. Both are vectors. Drift velocity and electric field both are vectors. This is the direction of electric field. This is the direction of drift velocity. Look at this. So direction of electric field, direction of drift velocity. They are in opposite direction. So what is that minus sign represents? In this equation, minus sign represents they are in the opposite direction. But the magnitude is the same as this. So finally what you highlight, the magnitude of the drift velocity of the electron is equal to this term EET by M. So this is how we arrived at the derivation for drift velocity. Remember, This is the one equation. The question asks for the derivation of drift velocity. Like this, how to derive this. So there is always thermal energy. The thermal velocity is there. From thermal velocity is drifting to electric velocity. We call drift velocity. So this electric current depends on drift velocity. That is how much of velocity it is gained due to electric field in this direction. And this is the one we have. So with all these equations, let us see that. Let us write some important equations of this. The conductor. About the conductor. Now write this Ohm's law equation. V is equal to IR. Let us write the important equations. About the electrical conductor. Study of the electrical material is important. Physical property. This property of the nature, property or characteristic property of this material. Study is very important. So write this equation Ohm's law and potential applies. So we can write this is V is equal to EL. What is EL? Electric field and the length of the conductor. Why? You derive from definition. What is electric field? Recall this definition. Electric field is the rate of decrease of potential with distance. Rate of decrease of potential with distance. So in integral form, ER is equal to V. R is a distance. Here the distance is distance between these 2 points. Distance between these 2 points. Between these 2 points we apply voltage, potential. This is potential. So R is L. So we can write V is equal to the potential. What you applied is same as EL in terms of EL. And let us write R also in terms of what is that? So L by A. What is L? It is proportional to length of the conductor, inversely proportional to area of cross section. Remember, resistance of a conductor resistance of conductor is directly proportional to length of the conductor and inversely to area of cross section of the conductor. So this R is equal to proportionality constant into L by A. In this equation, this rho is called as proportional constant. This rho is called as resistivity of the conductor. One more term. That is resistance of the conductor. It is called resistivity of the conductor. This resistivity is called as also specific resistance. The specific resistance is defined as, that is resistivity is same as resistance of the material of unit volume, that when length of the conductor is 1 and area of cross section is 1. So resistivity means resistance of the conductor per unit volume of the conductor. So this is one more equation. So equation for R we can write, equation for E we can write, and equation for I we can write the same thing as drift velocity. And as you know, substitute for drift velocity, this is 1. So all this, you put this into equation 2, 3, 4 into equation 1. Let us see what the equation we get. This is left hand side V. This is I, where Vd is substituted. This is 1, and that is R. And simplify the equation, what we get? E cancel, LL cancel, AA cancel. Remaining is this. Finally, it is rho is equal to M divided by N into E square T. Look at this, resistivity in the material is equal to M divided by N into E square T. What is resistivity? Resistivity is a property of the material. characterizes the material. So M means electron mass, it remains same electron in all material. It is electron charge, he carries electron charge, this is constant. Only thing, the variables are N and T. What is that? Number of free electrons of the conductor. It changes from material to material. One atom can give one electron, or in some cases one atom can give two free electrons. In some cases one atom can give three free electrons. In that case, what is that? N changes. And T means relaxation time. This relaxation time, this is what is that? This relaxation time is different in different material. So these two characterizes the material. Therefore, overall the resistivity is characterized by the material. This is about the resistivity. Now write the resistance in terms of this. What is that? Same thing, L by A. Or in terms of this. And one more important definition. The resistivity is inverse of this, that is sigma, it is called conductivity. So here resistivity, conductivity are inversely related, similar to resistance and conductance. I said resistance and conductance are inversely related. Resistivity and conductivity are inversely related. That is, rho is equal to 1 by sigma. Sigma is called, what is that? Conductivity. So you can write conductivity as inverse of this. That is, denominator becomes numerator, numerator becomes this. This stands for conductivity of the material. This equation is the conductivity of the material. This equation is the resistivity of the material, because this important equation, it requires for the discussion of resistivity of the material, temperature variant and also material variant and also conductivity. Now one more equation you can get. V is equal to IR. Write this equation, Ohm's law. Right? V is equal to this EL and retain height R as this, and simplify this. I by L cancel, I by A. This I by A ratio is called as current intensity by area cross section. It is called as current density, one more term. The ratio is called as current density, ratio of current to area of cross section, that is J, current density, that is J. So you can write in terms of current density, rho is equal to E by J. This ratio is called as electric field produced in the material divided by current density is called as resistivity. It is in terms of conductivity, inverse of this. These are the equations are very important. In terms of this current density, the resistivity and conductivity. By experimental measurement, you have experiments and you have different, what is that? The experiment can be conducted on different materials. And all the materials, when you calculate the values of resistivity and values of conductance can be calculated by experiment. All materials. Here, the resistivity unit is ohm meter. Conductance means Siemens per meter, inverse. Ohm meter, Siemens means per ohm. Either it is Siemens per meter in SI. That is resistivity values when you found for all the materials. If the value lies in this range, that is very low resistivity. Some materials have very low resistivity. If the resistivity values are found in this range, they are called as conductor. If the resistivity value of the materials are found in this range, that is very high resistivity, they are classified as insulator. Materials insulator. So they have the resistivity in this range, very high resistivity, very low resistivity, and the resistivity values lies in between this range. If they comes in this range, they are called as semiconductors. Look at this. On the basis of the range of resistivity values, we have classified the materials, all the materials into conductors, semiconductors and insulator. It is on the basis of this. Also it is the same as on the basis of conductivity. This is the conductance, very high conductance, very low conductance. The conductance intermediate of this is called as semiconductor. And the semiconductor, as you know, this conductor, insulator, semiconductors, the materials today, as you know, you have revolutionized in the field of software, semiconductor materials. These semiconductor materials, the conductance lies in between, neither a good conductor nor an insulator. The conductance semi, less conductance. And one more concept is very important, newer materials, very recent age, that is the recent study you come across. So material like superconductors, super insulator. On the basis of this, we have discovered that, of course, very low temperature. In some materials are alloys, making alloys. The resistivity values is 0. If rho is equal to 0, what is sigma? 1 by 0 is equal to infinity. So sigma means, infinity means conductivity, infinite conductance. Look at that. Conductivity, the conductance is, what is the value? Unimaginable, abnormally high, infinite value of conductance. That is no resistance at all. The material has no restriction, zero restriction. Full, what is that? Electric current. That is called superconductors. They have their own applications, but still we have what is that? Lacking application. What is that? Still you are not able to find out the efficient superconductor at room temperature. Very low temperature, no discount it, of course. Similarly, if that is the case, if rho is infinity, very high, that is infinite value of resistivity, that is sigma is equal to 1 by infinity, that is 0. Zero conductance or infinite resistivity. It is called insulator, it is super insulator. No electric current flow. Any amount of voltage you apply, no electric current flow at all. Not even a small amount, yeah, very micro amount of electric current. That is called as super insulator. So these are what is our newer materials, and we are materials of this found their own applications in our fields of technology. That is engineering technology, software technology, and all this. So you are going to develop, that is superconductors, supercomputers, or super material. Lot of applications you come across. Still, the application that is we are lagging behind discovering the superconductor room temperature. There is only a disadvantage. With this, we have what is that? Very important is about the material. Materials are classified into all the materials, solid materials classified into this conductor, insulator, semiconductor. They have their own, there are numerous materials you have found, numerous applications, and also superconductor yet to discover, super insulator yet to discover. With this, they have completed this. Yes, right up.